Hello everyone. So we are going to start the first unit of pharmaceutical engineering. So in the first unit we have the topic of the flow of fluids. So being a person from a pharmaceutical background, we need to study the different engineering behind the production process of different dosage form. So in this particular subject, that is your pharmaceutical engineering, we are going to deal with all such process and the different activities which are generally encountered in the production plant, starting from the preparation of a drug molecule till its final product. That may be either your solid dosage form like your tablet, capsule, pill, or it may be the liquid dosage form like solution, lotion, elixir, suspension, etc. So without wasting any time, let's start the first unit, that is the flow of fluids. I have made different parts. So first of all, let's start the part 1 of flow of fluids. So first of all, the fluid flow. If somebody asks you, define the fluid flow. So what is the fluid flow? By the terms of the definition, a fluid can be defined as any substance which continually deforms or it flows under an applied shear stress. Here the applied shear stress, it refers to the external force you are giving. Suppose you are having a glass of water. Now if we pour this glass of water on the ground, the pouring activity which led to the change in the angle, right? Earlier the glass may be perpendicular to the ground, but once you have make it in the 0 degree, it will flow due to the force. Now what is the force you are applying? You are applying just the gravitational force, that is the pull of the gravity, that is the small g, right? So the fluids, you can say they are the subset of the phases of matter, because we know that the matters, they are generally divided into 4 basic classes: the solid, liquid, gases and semi-solid, right? Now the fluids can be also defined as a subset of the phases of matter, which includes actually that this fluid, they actually include basically the liquids, gases, or sometimes both, because this liquid and the gases, they remain in the interchangeable forms. The liquid may get converted into the gases, or the gases may get converted into the liquid in any moment of the time based on the external factors like temperature, right? Moreover, the fluid flow may be defined as the flow of a substance that do not permanently resist the distortion. Means the fluid, they never resist the distortion. When you are pouring the glass down in the ground, the fluid, it will go immediately to the, or it will fall immediately on the ground, right? When you are opening the tap of the water, the flow of the fluid will go, or the water will come out from the tap, right? These, or the liquid or the fluid, they never ever resist the distortion, the external force, right? So the subject of the fluid flow can be divided into basically 2 types. First one, it is your fluid statics, first one, it is your fluid statics, and the next one, it is your fluid dynamics. So in the statics, we are going to deal with different properties of the fluid in the static moment, whereas in the fluid dynamics, we are going to study the different properties of the fluid in the dynamics or in the motion, right? So identification of the different type of the flow, it is important in the pharmaceutical engineering. Why? Because see, it is necessary in terms of manufacture of dosage form. If you don't know what the vehicle you are using in the formulation, suppose this formulation may be your gel, this formulation may be your suspension, this formulation may be your lotion, right? If you don't know the type, then you will face the problem. Next, handling of the drug for administration. Suppose there are different types of the drug which are available in the market in different forms. So in general, we don't always use a oily vehicle for the intravenous administration. We don't use, but for muscular you can use a oily vehicle. Thus you should know what type of the liquid you are using for administration. For this you need to know the properties of fluid flow. So basically the properties of the fluid, three properties are there. First of all, it is the viscosity. We are going to discuss in details in the coming slides. Next one, it is the surface tension. Then it is the compressibility. So first of all, viscosity. Viscosity can be also defined as the resistance. So viscosity, it is a measure actually of fluid resistance to flow. Means the fluid, they always try to resist the flow. If you are pushing the fluid towards a direction, it will always try to resist. But which layer or by which force? Basically, you see, there are two types of forces. The first type of force, it is known as the adhesive force. The adhesive force, it is a type of force which always occur between dissimilar matter. Like the liquid, it is having the adhesive force of attraction between the glass, or you can say, suppose you are having or you are holding a glass of water, the layer of the liquid which is in contact with the steel of the glass, it is having a adhesive force with that of the glass. But what is the cohesive force? The cohesive force is a force which occurs between similar type. Means the liquid molecule will appear or apply a cohesive force on another liquid molecule, right? So this viscosity describes the internal friction of a moving fluid. A fluid with a large viscosity, it always resists the motion because its molecular makeup gives it a lot of internal friction. And similarly, a liquid or a fluid with a low viscosity, it flows very easily because its molecular makeup, it results in a very little friction when it is in motion. For example, for this case, let us consider a river, a flowing river. In a flowing river, we always find different motion or different velocity at different point. Suppose if we consider a section of the river, in the topmost layer of the water which is flowing at the top of the river, it is having a free flow or it's having a more velocity as compared to the most lowest layer which is in touch with the ground, because the lowest layer which is in touch with the ground, they will have a adhesive force with that of the ground, or you can say soil, which generally resists. The next layer, it will have quite less adhesive force. The next layer above, which means above this layer, it will have more less in this way, and the top layer, it will have negligible amount of adhesive forces. Thus the topmost layer, it flows very fast, whereas the lower, or you can say the bottom layer of the water, it has a very low motion, or you can say it will have a very low velocity. For example, you can see here I have placed 5 test tubes. Here they are having different fluids. So in this case, you see this is a free flowing. Here the viscosity it is very less, right? Here the viscosity is quite greater as compared to this one. Here it is more, here it is far more, and here it is excessive. So in this way you can see that as the viscosity it increases, the flow of the liquid it decreases. Clear? The next part, it is the surface tension. So what is surface tension? Surface tension is nothing but it is the contractile tendency. It is the contractile tendency, means the force between the water molecule is more. That is the cohesive force between the water molecule is more, which actually resists in the, or which actually resists the extension. For example, did you ever notice the water droplets over the leaf of colocasia? Or in our general language we used to say it, in Assamese we used to say it kosu, right? So they always remain as a droplet, right? Why it happens? It happens because these water molecules, they have high amount of the cohesive force, and these water molecules or this droplet of the water molecules, they resist the extension. They resist the extension of their surface, right? So the fluid tends to attain minimum surface area as possible. Means the fluid, they never try to expand themselves, but this surface tension can be reduced when we are going to use any external force. Now, any force you are going to use to increase the surface area of a drop of liquid is equivalent to its surface tension. Okay, so why? The reason behind this is that while a molecule inside the fluid, a molecule of the liquid inside the fluid bulk means in the between, it is pulled in every direction by the adjacent molecule, that is the cohesive force. And the molecule which is at the surface, it is having adhesive force, and moreover it is also having, or it will also feel the cohesive force due to the downward pull from the bulk. So the molecules on the surface, they tends to move down. Let's have one example. See here, this is the surface, right? This is the force that is remaining at the surface. So a molecule at the top, this force, the net force on this molecule, it is into the bulk of the liquid, means the bulk of the liquid, it is pulling this molecule downwards. But here, as the molecule, it is in the bulk, this is at the surface and this is at the bulk. Here this molecule, it is being pulled in every direction. So here the overall force, you can say it as a zero, as because everywhere it is being pulled, but here there is a force, total summation force. Here it is pulled in the bulk or towards downward region. So if we calculate, have you ever noticed a spider crawling over the surface of the water, how it seems like? This is because of the surface tension of the water. This water, they never lets to break due to the high amount of the cohesive force. So how you are going to define the surface tension? The surface tension T is equal to F by L, where the T, it is the surface tension of the liquid, right? F, it is the force per unit length. This is the force per unit length this molecule is getting, and L is the length in which the force it acts. So this is the example. I have already told you the water droplets which are falling over the leaf of colocasia, right? Now let's have a discussion on fluid statistics. So fluid static deals with the fluid at rest in equilibrium. Here the fluid will remain at rest, no movement will take place. Moreover, the fluid static, it generally deals with the behavior of the liquid at rest, the behavior of the liquid at rest, and the nature of pressure it exerts. This liquid will exert, and the variation of pressure at different layer. So the pressure differences between the layers of the liquid, it is studied in the fluid statistics. So here we are going to conduct one experiment virtually, right? So here you see there are two cylinders. These are look-alike cylinders, with the same height and all. So here you are having 2 points. This is the point 2, this is the point 1. I am showing the similar one here. So this is the point 2, this is the point 1. This point 2, it is at the height of h2, and point 1, it is at the height of h1, right? So let's start the experiment. So let's consider a column of the liquid with two openings, right, which are provided at the wall of the vessel at different height. These are provided at different height. So generally this, if we see, this liquid will fall at quite more distance as compared to this one, because here the amount of the force, or you can say the pressure, it is more, because it is in a more height as compared to this one. So here the force is less, but here the force will be more, right? So the rate of flow through these openings are different due to the pressure exerted at different heights, right? We know that. So let us consider a column. This is the pressure, right? So let us consider a stationary column with the pressure PS. So here PS, it is the stationary pressure PS, right? It is acting on the surface of the fluid. Now this column is maintained at a constant pressure by applying pressure. Here we are applying the pressure. Let's study how or what is the pressure difference. So again we have to consider the same thing only, right? Here the first thing is that the force acting below and above the point 1, the force acting below here and above the point 1 are evaluated. How we are going to evaluate? See, we know that what is pressure? By definition, pressure is equal to force acting per unit area, means P is equal to F by A. From this equation, if you want to take the F, then F is equal to P into A, right? That is the force is equal to pressure into area of the cross section, right? So let us consider the pressure at point 1, which is denoted with P1S, that is the stationary pressure, is equal to the P2S, this pressure, plus volume, this volume, right, into density of what? The molecule or the water molecule into acceleration due to the gravity, right? So here again you see this can be more derived or illustrated like P2S plus volume. It can be also defined as a height into area, right, into density into the acceleration. Volume we have replaced with height into area, right? So thus you can say P1S is equal to P2S plus H. S, it is the surface area, this is the density, this is the acceleration due to gravity, right? So since the surface area is same, right, since the surface area is same, so we will consider it in a simple way, that is the P1 is equal to PS. Surface area is same, so we are considering as P1 is equal to PS, that is the overall pressure, plus H1, this height, into the density into the acceleration. Similarly, the pressure acting on the point 2 can be written as P2 is equal to the partial pressure into height 2, H2, this is the height, right, and into the density into the acceleration. So the difference in the pressure, just subtract it, P2 minus P1. So here you take common you take out the G as a common, right? From here pressure, change in the pressure delta P is equal to, finally you will get H rho G. So H rho G, it is the difference in the pressure between these 2 points, right? So the next thing, it is the fluid dynamics. So here we are going to study the properties of the fluid in the motion, right? So fluid dynamics, it deals with the study of the fluid in the motion. So this knowledge, it is important. Why it is important? Because it is needed, this information is needed during the formulation of liquid, gels and ointments. For example, or for an add-on knowledge, I want to share you one thing, that all of you have seen the gel, right? The gel, the gel, it is a set, or you can say it's a states of matter between the solution and the semi-solid. So if you ever apply the gel, any sort of gel, over the face or over your hair, when you place the gel over your palm, you rub it, this gel immediately get converted into solution, sol. So this is known as the gel to sol conversion. And the similar solution, if you freeze it, right, this solution will get converted into gel. So this is known as gel to sol, sol to gel conversion. These type of things, these type of parameters are needed, and this all we get from the study of the fluid dynamics. So this knowledge is important for the liquids, for gels, ointments, which will change their flow behavior when exposed to different stress conditions, like your external force, like your external temperature. Thus you see, the fluid dynamics, it is needed in the process of mixing of the drug with the vehicle, even flowing of through this mixing of the drug and vehicle, then their flow through the pipes, even during the time of filling in the container. So Importance, basically you see identification of type of flow is very important in pharmaceutical field, because we know that we have already discussed manufacture of different dosage form, moreover handling of the drug for the administration, right? So the flow of the fluid through any pipe, it can be either your viscous or turbulent. We are going to discuss what is a viscous flow, what is a turbulent flow, and it can be determined only by using the Reynolds number. So the Reynolds number have no unit. So what is Reynolds number? Let's discuss the Reynolds experiment. So here, if we see, Reynolds has considered an experiment. He has taken a glass tube, right? This glass tube, it is attached to a water reservoir through a valve. From here the water is coming. Moreover, he is having a colored solution here in another reservoir. From here, through a nozzle, suppose a nozzle of a syringe, he is allowing, this is a colored liquid, suppose ink, he is allowing it to flow through. Now this ink, it may either go straight, without any distortion, it may have a laminar flow, or it can have a turbulent flow, or the ink may get mixed with the water. So this experiment was actually done by the Reynolds. So what he has done, he considered a glass tube which is connected to a reservoir, water reservoir. The rate of the flow of the water, it is controlled by the valve, and a reservoir of color solution is here, which is connected through the nozzle. Now through it the ink, or you can say any color dye, it is injected as a fine stream. So he is Reynolds. So full name of Reynolds he is Osborne Reynolds, right? So he was the pioneer in fluid mechanics. So he have discovered the nature of flow of any liquid. It depends on few criteria. What are the criteria? Number one, velocity. Number two, the fluid physical properties, right? Like its viscosity and all, right? Moreover, geometry of the channel or the pipe, whether the diameter of the pipe is small or it is more, right? Moreover, sometimes the flow is even or smooth, or sometimes the flow may be uneven or rough. These all factors actually controls the nature of the flow, right? So he has investigated the fluid flow using this apparatus, which we have already discussed. So here, this is the dye, right? It is having a fine flow. So what he has found, that at a very low water flow rates, I'm not talking about the dye, I'm talking about only the water. In the previous one, again I am showing you not to get confused. Here, this is the water, this is the colored ink, right, or the dye. So again I am saying you the same thing only. See what he have found, that at the very low water flow rates, the dye, they never break up, they just flow in a single line, right? This means the dye and the water, they never mix up. But at a high water flow rate, this dye, it break up, and the dye is mixed with the water, giving a color to the water. So what actually happens? So Reynolds experiment. So what he have found, that at the low flow rates, we get a streamline or laminar flow. Laminar means flow in a layer. The flow is characterized by the streams. The flow is characterized by the streams which don't mix up. But at a high flow rate, we get a turbulent flow and lots of mixing, means the dye, it mix up with the water. So the laminar fluid get converted into turbulent flow. Turbulent means mixing with the increase of the velocity. He has found it, the first one, the velocity. Next, Reynolds, what he has done, he has heated the water. Upon heating the water, he found that when heated, the change from the laminar to the turbulent occurs sooner. Means the laminar flow, earlier it was laminar, but afterwards it get turbulent, means this dye mixed with the water. Once the temperature it is high, this is explained by viscosity actually. As the viscosity decreases, we know that the viscosity of any liquid, it decreases with the increase of temperature. Thus you can say the laminar flow, it get converted into the turbulent flow, right? It led to the decrease of viscosity. The next thing what we have observed is that Reynolds has replaced the water with liquids of different other density, means other liquid, this may be organic liquids or oil and like this. So what he has found, the change from the laminar to the turbulent, it occurs sooner for a high density liquid. Thus the laminar to the turbulent flow, it happens with a high density liquid. The next one, the Reynolds used the tube of different diameter, and he observed that the diameter, as the diameter you are going to increase, the means if the pipe diameter is increased, it immediately get converted into turbulent. So here you can see in the smaller pipe size you will have a laminar flow, whereas in the bigger pipe size you are having a turbulent flow, right? So this is the laminar flow. See, they are moving in the layers, but this is the turbulent flow. So these are suppose dye molecules, they are getting mixed with the water molecules. So the laminar flow is the one in which the fluid particles, they move in the layers. The fluid particles, they move in the layers, or the laminar with one layer sliding over the another. When I have told you that this part here, you see this layer, it is directly in touch with this wall, right? It will have a less motion because it is exerting a adhesive force over this layer. But here this layer, it is quite free because it is far at a distance from the wall, right? So it will move fast. So this is the way how it moves. Next thing is that there is no exchange of the fluid particles from one layer to another layer. This fluid particle, they do not exchange because this fluid particle which is nearby to the wall, this is having a adhesive force which is pulling it towards the wall. This next one, it is having adhesive force also, but it is less as compared to this. This is having a more adhesive force, right? And this is having a zero adhesive force, so it can easily move out, right? The next thing is that when the velocity of the water it increases, when the velocity of the water increases, the thread, that is, the thread means the lines of the liquid or the colored water, it disappears, and the mass of the water, it get uniformly colored, because when the velocity increases, turbulent flow, or you can say turbulence, it occurs, which results in the mixing of the dye with the water, right? The next thing is that the velocity at which the fluid changes from the laminar, you should remember this, the velocity at which the flow of the liquid changes from the laminar flow to the turbulent flow, it is known as the critical velocity, right? So Reynolds number. So in the Reynolds experiment, the flow conditions are affected by conditions. What are the conditions? First of all, the diameter of the pipe. Next condition, average velocity. Next, density of the liquid. Next, viscosity of the fluid. So these four factors are combined, and this combined factor, it is known as the Reynolds number. So Reynolds number R, it is defined as simply inertial forces divided by viscous forces. So what is the inertial force? Simply inertial forces are due to the mass. Inertial forces are due to the mass and the velocity of the fluid particles trying to diffuse the fluid particle. This is the inertial force. Inertial forces are due to the mass and the velocity of the fluid, right, trying to diffuse the fluid particle. And viscous inertial forces are acting in the middle layer, whereas the viscous forces, they are acting in the outer layer adjacent to the wall of the pipe. The viscous forces, it is the frictional force due to the viscosity of the fluid, which makes the motion of the fluid in parallel. Thus you can say, or here Reynolds number can be also defined as, see, these are the simple thing only. Here D, it stands for the pipe diameter. Here it is the capital D, right? Next we have the density. Here also it is the rho, Here I am defining the velocity with u. Here I am defining the velocity with mu, right? Here the viscosity with the eta, and here the rho. That is the difference. The thing or the formula, it is same. Some text use this formula, some text use this formula. Now you should know that at the low velocity, the inertial forces are less when compared to the frictional forces. At the low velocity, the inertial forces are less. Thus, at the low velocity, the water or the dye, color dye in the experiment, that color dye, they always move in a laminar fashion, in a layer, right? Resulting flow will be viscous in nature, right? On the other hand, when the inertial forces are predominant, the fluid breaks because you are having a high velocity. It breaks up due to the increased velocity, and hence you will get turbulent flow. Here the dye, it will mix up with the water, giving the color to the water. Thus, the significance of the Reynolds number, if the Reynolds number it is less than 2000, the fluid flow, it is said to be laminar, and if it is more than 4000, the flow is said to be turbulent. And if the Reynolds number is in between 2000 to 4000, the flow changes between laminar to turbulent and vice versa. Clear? So, application. The Reynolds number, it is used to predict the nature of the flow of any vehicle, which are used in the formulation of different dosage form. Moreover, the Stokes law we are going to discuss in the upcoming presentation. The Stokes law, it is modified to include the Reynolds number. In the Stokes law, we have modified it to use the Reynolds number to study the rate of sedimentation in the suspension. We know that what is a suspension? Suspension is nothing but it is a homogeneous mixture of two immiscible substances. The solid substance will remain as a fine powder, whereas the liquid will remain as a dispersion medium, right? So the Stokes law, it is used to check the sedimentation in case of the suspension or pharmaceutical suspension. So when the velocity is plotted against the distance from the wall, when the velocity of the liquid, it is plotted against the distance from the wall of the pipe, the following conclusion can be drawn. What are the following conclusion? See, the flow of the fluid in the middle, of the pipe, it is faster because it is having a more distance from this wall, right? It is freely moving than the fluid near to the wall. This layer will have less velocity, as because it is having a less distance with compared to that of the wall, where the adhesive forces, it is acting between the wall of the pipe and the liquid, right? The actual surface of the pipe, you can say the wall of the velocity of the fluid is 0. So at this surface, at the wall of the pipe, the velocity of the fluid can be considered as a 0, because the fluid which is in the middle, it is only flowing, so it is having the turbulent flow, right? So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates, and for further notification from this channel, you can subscribe my channel. So thanking you once again. Thank you.